let's look at the extensive challenge number 2. This question is from Intermediate Math Challenge, and it's a very interesting question. So, if PQ are distinct primes less than 7, what is the largest possible value of the highest common factor of 2p squared q and 3pq squared? Okay, so let's first think about where can we make a start. So for sure, the first sentence, distinct primes less than 7. There aren't that many of them, so let's just try to list them down. So I would have 2, 3, and 5. Okay, and here, these are two numbers. So this means 2 times p squared times q, and this means 3 times p times q squared. That's just what it means. All right, so there are different combination or choices for the value of p and q. So of course, there are different values for the highest common factor of these two numbers. But if we look at these two numbers, we'll see that what they have in common for sure is p times q. So this is actually like their common factor. No matter what the value is for p and q, you always have the common factor of p times q for these two numbers. And why would it be the largest possible? Let's see what happens. So I'm going to write these two numbers down. Okay, so we can see that, okay, so here I have 2, I have 3, and the possible value for p and q is also, they also have 2 and 3. So what if the value of p is 3? If this is 3, other than the p times q that they share in common, the first number will also share another 3 with the second number. So in this case, the highest common factor of these two numbers will then be 3 times p times q. And the same is true for if q, the value of q is 2. And then think about what will happen. So if q is 2, then the second number is going to share another common factor of 2 with the first number. Then the common factor of these two numbers will become 2 times p times q. Okay, then let's look into these two cases. For the first case, if p is 3, then the common factor of them would be, if this is 3, would be 9q. And with the second case, if q is 2, then the highest common factor would be 4p. This is 2. Okay, in that case, then let's see what are the possible values for p and q here. So if p is 3, then you can choose q from 2 and 5. If you want it to be larger, of course, you want the value of q to be 5, the larger one. And then that would then be 45, 5 times 9. And for the second one, if you want this to be larger, you can choose from 3 and 5. And if you let the value of p be 5, then the highest common factor would be 20. And if you compare these two, this would give you a larger highest common factor. Okay, therefore, for the final answer for this question, what's the largest possible value of the highest common factor? It's 45. And that is when p is 3 and q is 5.